The event itself is a co-hosted event between CWEM and the Environment, Water and Environment Society of Engineers Ireland. So welcome everyone who's tuning in today. And our two speakers today, Rosemary and Stephen, will be talking to us about the Flood Forecast Centre at Éireann. So our two speakers, well, first of all, thanks very much for agreeing to give the talk today. And we're really excited to hear about this project. So a very brief biography for people who haven't come across Rosemary and Stephen before. Rosemary has been working in this area. She's a chartered engineer and hydrometeorologist, and she has over 20 years experience in this area, but she's also done some work in the area of roads and overseas work in integrated catchment studies, SUDS projects and that kind of thing. So I think maybe it's safe to say that for now, the Flood Forecast Centre is the main focus. So also then Stephen similarly has a civil engineering background. He's held multiple roles with local authorities, as well as working with stakeholders in the development of the National Flood Forecasting and Warning Centre, and in particular looking at the communication strategy. One other thing we didn't know about Stephen: he's an avid but poor golfer. So there we go. So anyway, so without further ado, I think we'll start off. Rosemary's opening the talk, is that correct?
That's correct.
No, Stephen's in the middle. Anyway, whoever's going first. Yeah, great. If you could proceed then, and if there's anything you want to add in by way of introduction that I have missed, please let me know.
Thanks, Sheila. So today, as promised, we're going to talk to you about the background to the service, the methods and means of flood forecasting, the communications of flood risk, and the road ahead of the service. I'm going to be covering the background of the service. Stephen is going to come in and talk about methods and means and the communication, and then I'm going to discuss where we're heading, the road ahead. So let's start at the background. So where did the idea of flood forecasting come from? The severe flood in November 2002 affected the country, especially in the River Talca in Dublin, with Bertie in his boots, as you can see here on the left-hand side of the presentation. This resulted in the production of the Parliament report in November 2002. The report designated the OPW as the leading agency for management of flood risk in Ireland and listed a number of potential flood risk management solutions, including flood forecasting for the OPW and other state bodies to start working on. In 2009, 7 years later, there was twice the average annual rainfall for November, which measured at all of Met Éireann stations, and over 3 times fell in some places. This resulted in then record river levels with widespread river flooding. The OPW then commissioned JBA to carry out a report and a strategic review for options for flood forecasting and flood warning in Ireland. This came to be known as the JBA report. So then in 2016, Storm Desmond, Eve and Frank hit the country. They all produced heavy rainfall amounts with flooding continuing in several parts of the country until mid to late December 2016, especially in the Shannon catchment and Cork. This led to the government decision in January 2016 to proceed with stage 1 of the JBA report. The key action was to establish a national flood forecasting service with the operational unit known as the Flood Forecasting Centre to be within Met Éireann. And this is where myself and Stephen are speaking to you from today. This lovely green was provided by the OPW as part of the funding of the setting up of the Flood Forecasting Centre. So what is the objective? So OPW's policy for the implementation of the flooding of the National Flood Policy, along with flood risk measurement plans, has a non-structural measurements. And one of these is, which we were very familiar with. So what are the measures? So when we're talking about flooding, we're talking about the implementation of the National Flood Risk Policy published by the OPW, the flood plan the flood risk management plans, which have been published by the OPW. We're also talking about planning guidance, individual property protection, developing community residual, and of course, flood forecasting. And just for all those lovely, keen people working in the local authorities, the planning and system and flood management system is the other kind of really non-structural flood relief measure which engineers will be most familiar with. So between the planning system and flood forecasting, we're not just doing physical actions in relation to flooding, we're doing softer approaches. So what is the National Flood Forecasting Centre? The aim of the National Flood Forecasting and Warning Service is to ensure the effective delivery of operational flood forecasting products and flood risk information to its stakeholders. This information helps the stakeholders to make impact-based decisions and take actions that will protect against the loss of life and that will protect and mitigate against damage to property. The government decision in 2016 appointed the operational element of the service to Éireann. Éireann had the experience as an operational weather forecast since 1936, so we were in a good position to provide this service. A flood forecasting centre was to be established in Éireann. This will be manned by hydrometeorologists like myself and Stephen, and they would be tasked with maintaining river and coastal flood watch over the country for stage 1. The OPW will provide guidance and standards to the centre. In stage 1, we are working at the river and coastal level at a national level for the coast and at a catchment level for the river. The governance structure of the National Flood Forecasting Centre Warning Service consists of an interdepartmental flood policy group, the steering group and the Flood Forecasting Centre in Éireann, subgroups to the steering group for comms and technical issues, and OPW as an oversight unit. The steering group has representatives from Éireann, the OPW, the Department of Local Government and Housing and Heritage, and the Department of Ag, the Marine and the local authorities, the CCMA, the Flood Forecasting Centre subgroups for comms and technical issues. And so that's kind of gives you an idea of the structure and corporate governance over the Flood Forecasting Centre. So why Éireann? We are the Meteorological Service of Ireland. We have the weather experts who just sit behind me here. We operate on a 24/7 service. We have an operational coastal ocean models that are access. The public trust us and we're used to issuing weather warnings, and we have a large public engagement. So what kind of public engagement did we have? Well, this is an old slide from 2019 to 2021. In a 24-month period, Éireann had only 144.8 million hits on our website. And as you can see, the hits are, when a storm happens, we tend to get more hits. So for the likes of Storm Lorenzo, we got 1.5 million hits in a day. But on any average day in Ireland, we get 200 hits per day, 200,000 hits per day, which is quite a lot for prior to COVID, we were the biggest interaction of a government website in the state. But the COVID and the HSE took us over on that stat after what has occurred over the last 2 years. So where are we? So some context for you on our mission statement is that the FFD is a service division, and we will be providing a valuable service to the people of Ireland through the provision of timely and accurate flood advisories and alerts. Éireann's strategy, Making Ireland's Weather and Climate Prepared Strategy goal is to deliver a high quality national flood forecasting service. In order to achieve this, we place the customer at the centre of our plans. The delivery of the service is divided up into 3 stages in the JBA report. Stage 1 is the establishment stage, which was started in 2016 and is meant to be running to the end of 2022, probably into 2023 at this stage. We have 5 key elements which we are focusing on, and they are: number 1, resources, which is recruit and train staff like myself and Stephen into the section. So back in 2016, there were 0 people working in flood forecasting. There's now 8 people. 4 of the people have backgrounds in civil engineering, funny enough. Accommodation for staff in Glasnevin, myself and Stephen are sitting in the new headquarters for the Flood Forecasting Centre, which has been accommodated within Éireann's building. Identified and developed optimum river models for use at a catchment and national level. Introduce national coastal modelling into the capacity within Éireann's suite of operational forecast models. Develop a communication strategy for the service and establish interim operational arrangements before training the non-operational end of stage 1. So trial and testing of our flood forecasting capabilities and procedures and systems. So that's what stage 1 is all about. And we will go into more details on where we are with all these. And for that, I'm going to hand you over to my colleague, Stephen.
Just get my slides up again in front of me here, sorry. Okay, so as Rosemary said, we're in the middle of a trial and a testing phase of it's a non-operational trial. I'll explain that in a few more minutes, just in some of my slides. But what I want to talk about is what we're actually testing and what we're trialing at the start. So where we were, it's always a good place to start is at the start. When in 2016, what was there? There was a few existing FLUVIAL models, such as the OPW's models for the Lee and the Shore and the Blackwater as well. There also was the European Flood Awareness System, EFAS there. So they were the existing flood forecasting models that were covering Ireland. But for the rest, that's a very, very small area. It's only about, well, EFAS does cover the whole area of Ireland, but at a large scale there. But for, we'll say, sub-catchment models such as the Shore and the Lee, it was a very small percentage of the population that are actually covered by, we'll say, FLUVIAL models. So we had to look. We hired in association with the OPW, we put out a tender to examine and what actual models were out there internationally and nationally, and what integrator systems, or we'll say schedulers, were out there for running the models there. So we worked with a company called IMDC, who got the contract there, and we started to look at the actual models. So we actually asked them. We completed a literature review of what models were out there. We sorry, I went through a little. What models were actually out there? What operating systems and integrators were out there? And they produced a report. And from that report was that the most suitable models to be used in Ireland was the HYPE model from SMHI, and the most suitable integrator or scheduler was the Deltaris fuse from Deltaris. So as part of that literature review, we asked them to build models, to build 5 models. It was the Shannon, the Barrow, the Slaney, and the Moy Killala. We asked them to look at the different suite of integrators that were out there and the different suite of models, to test them, to trial the integrators, to trial the models, and to complete a report. During that trial, we actually increased the area. We asked for another 7 catchments, hydrometric areas, to be included in this trial. And this was included, and it was in, as I said, the findings of this actual review was that HYPE was the most suitable model, hydrological model for Ireland, and FUSE was the most suitable integrator system to be used. So we have 12 hydrometric areas complete, and in fairness, that does cover much of, we'll say, not the landmass, but the population of Ireland there. But Ireland is created of about 40 hydrometric areas, but there's 36 of them that actually are cross-border between the Republic of Ireland and cross-border. So we had to build and develop the models, the HYPE model for the other. There was 12 built within this project, within our first project. So we had to build from scratch another 24 models for the remaining areas as well. So the HYPE model, as I said, is a semi-distributed hydrological model. It takes different conditions such as weather, we'll say topography, land use, and it uses a set of equations. Basically, like any model, it uses a set of equations to give, we'll say, a result, and that result is flow at a certain point. Now, HYPE actually stands for the hydraulic predictions and the environment, because we actually visited SMHI, and they actually use this model as well, not only for hydrological purposes, but it's used to evaluate nutrient values such as phosphorus and nitrates in the environment in Sweden. Now, we don't in Ireland use the HYPE model. We only use it as a hydrologic model. So that maybe there's scope in the future to develop that model into something further. But at the moment, it's the HYPE model from SMHI that we use. So as I said, a hydrological model gives us an output at a certain point. It gives us a flow at a certain point, and we have to evaluate and examine these outputs against certain thresholds, and that's how we use the models to use it as flood forecast. And an example we do here is how they use the models, hydrological models in Germany. There, they examine the actual outputs along in a hydrograph of a certain point against known thresholds there, and they compute the probability of flooding at a certain point. All our models were run by a FUSE system, and a FUSE system, if you think it is, we have 36 models and we run them 4 times a day. Actually, we run them 6 times a day. We run them for in relation to the Harmony forecast and ECMW forecasts, our weather inputs there. But to run that amount of models in a day, it's a huge computational problem. So we actually get a scheduler, our national FUSE system, and it takes in our models, it takes in our water level observations, it takes in our meteorological observations, and it takes in our forecast data, as I said, which is the Harmony and ECMWF. It goes into this, as we say, the black box of FUSE, and what it actually exports out, we can see it on a GUI, GUI there, we can see the results, but it also exports it in out in XML and NetCDF format, so we can look at it. It's on another system, as I said, IFEX, I'll be talking about that later, and we also archive this data there. So if you think of HYPE is the model that runs and export and predicts the actual forecast the hydrological forecast at a point. FUSE is the system we use to actually run each model, and it's to correlate them all and give us the results out in a fashion that we can interpret better. So again, our national FUSE is based on a 36 hydrological area catchment based models. It gives us, as I say, we can see the information in hydrographs, or we can see them in spatial data, or we can export them as CSVs or NetCDFs, or there's multiple formats we can export out of FUSE. But even the developers of FUSE says FUSE is not, it doesn't create pretty pictures. So we had to create another portal that we could export and visualize the data. And I'll just talk about that later on. That's our IFIX system. But so that's hydrological and fluvial forecasting. We also, as Rosemary said, we were tasked with coastal forecasting. So coastal flooding, I'll just a very quick overview of coastal flooding there. Coastal flooding, you look at there's 4 main components of coastal flooding, and that's waves, surge, swell, and tides. And an element of everything there we do whereas we have different forecast systems. We have a tide and storm surge forecast that we inherited from the OPW, and that forecasts the tide and the storm surge element of that. But it's in relation to the swell and the winds and the waves, and there's not one model that is integrated yet. Maybe at some time down the road we will have one unified model, but at the moment it's separate models we use to forecast for coastal flooding, and it's a mixture of, we'll say, the tide, storm surge forecast is one, and then a mixture of other models to get the other elements such as wave conditions and swell. So this is just an example of the output there that we have. This is an example of our tidal prediction at certain points throughout Ireland. For I think there's 64 points that we currently model prediction points for, and that's the tidal. This is an example of our surge forecast there, straight from the TSSF, and you can see we have a prediction of the tide. We have error bands there. We add the surge on to the tide prediction, and that gives us a total water level there, and that tells us our total water. And we we would compare and we would contrast this, and we would evaluate these forecasts of total water level against, we'd say, known thresholds such as HAT, which is highest astronomical tides, or the or other thresholds that are there, and we would make an evaluation of a forecast there then. So, and then just looking at on the forecast points there, there's an example of our forecast points where the TSSF points, are all around the country. They're all around that we have our forecast points there. It's currently only working on the ECMWF, which is the European medium range forecast, weather forecast there. There is plans to integrate it into have our own model, which is the Harmony model there, to integrate that weather data into it there. We are currently, it had been run by, I think it was RPS ran it for the OPW, and we have inherited the TSSF model there, and we're bringing it over to run it on the computer in ECMWF on the supercomputer. And this hopefully will allow us, as we say, to introduce maybe ensemble forecasts, or to add other weather models on to increase our accuracy there of our forecast points. And again, this is just an output there. The tidal and storm surge forecast there. For example, on the bottom is actually easier to go. That's our tidal prediction for a point in Arklow. The middle graph here, I don't know, sorry. Just go back. Yeah, the middle plot here is actually the storm surge there. Add these two together and you get an indication of your total water level. And like everything there, there's plus or minus there. That's the error band there that you could get. And we just evaluate them against known thresholds there. And that's how we forecast for, we'll say for coastal forecasting there. And as I said there, we are working to get this, the TSSF implemented on our, we'll say the supercomputer on ECMWF, and we're currently working on that. We're currently reviewing its running at the moment there before we run it operationally ourselves totally. So there's our models. I've told you our models there, and I've told you basically we have developed the models, we've developed the FUSE system, we've inherited the TSSF, we've incorporated the waves and other models there to have a look at this. So again, we have to test it. We have to test what we're doing, run it in a kind of a non-operational format that we can actually, I don't really like the non-operational, it's near operational is possibly a better word for it there. So one of the first things we have to do, and in the communications, we have to devise thresholds and to see when you have a forecast there, what you actually compare it to. So we have 4 thresholds: normal, elevated, high, extremely high. This is where we actually landed on there. We done extensive research on forecasts throughout, we'll say, forecast thresholds for flood forecasting throughout the world there. And it was kind of a combination. As I say, we're not copying off anyone directly. We're kind of copying off a couple of people there. So we deliberately stayed away from color coding because in weather forecasting, especially in a red warning, the actual terminology is there is to stay at home. And in floods, you shouldn't really, it may not be the right option to stay where you are in the flood. So we don't want people to stay where they are. We want them to listen, know what the flood risk is, but be also instructed by the warning itself. At the moment, so the notifications and how we were going to disseminate the actual notifications. So these are the 4 thresholds we have chosen. We are trialing our models there. As I said, it was 36 river models. We're trialing the TSSF, and we are trialing the communications that we intend to trial and to use in the system and in the service that we are providing there. So they're the actual 3 elements that we are trialing at the moment there. The trial is an 18-month trial. It's basically carried out since last October. We started delivering a daily flood forecast to the local authorities, and this is how we are testing how we are actually communicating and forecasting as well. We're looking at the communications, but we're also looking at how the level and the accuracy of our forecast as well. And we hope we kind of continue on that trial, and we hope to start the review of our trial in the next couple of months. So as I just alluded to there about communicating flood risk, if you're not actually telling people, you could have the best forecasts in the world, you could have the best systems in the world, but if you don't tell the people down in Cork or the people in Kerry that it's going to flood and they're still in the house when it does flood, then your system has failed. So this, I like this screen. This slide was devised by a colleague of mine, Kieran Broderick, and it just shows all the, we'll say, it kind of shows flood forecasting in one slide there. It's the collection, we'll say, of weather data, of meteorological data, of forecast data. It's also collecting radar observations, river level heights, and it's shown that we actually have to pass that data on to people. It's either to the media, to the public, to the local responders as well. So that's what we have. And in stage one, we're as we say, we're not live, so but we are testing how we will deal with our stakeholders, and that's what we've trialed. We're not really public facing at the moment on stage one. We maybe even not in stage two. Stage two has not been written yet, so we don't know if we'll be public facing at that stage, but we're just testing our communications now. And part of our communications is IFIX. We want to have one portal that any of our stakeholders can look at. It will take in all observations and all our forecasts. This is just a slide there, but it really is, it's a system where we'll say any engineer in a local authority could look at, and he can assess himself. He can see what we're seeing. He can see our forecasts. He can see our alerts or our notifications. He can see our forecast there. He can see the information we're seeing, and it will help him make the decision of what he has to do next. So that's what we hope IFIX will be. We call it it's the Irish Flood Integrated Communication System, and we want it to be integrated because we're trying to include as much as we can within IFIX. And as I said, as part of the trial, we put out a flood forecast, a daily flood guidance statement. Which is our flood forecast, is our daily flood. It's our first. It's a broad. It's our first attempt of a flood forecast. We want it to be better, but at the moment, what we do is we are forecasting on a national and a catchment scale. And as our thresholds, it's county based. We show the thresholds of normal, high, extremely high. We tell them what they are. We give them a summary of weather, but it's not very pinpoint accurate, or we would hope in the future, and Rosemary will talk about what we can do in the future. But at the moment, the daily flood guidance statement is our daily forecast there. So also we would have risk maps. This on the left hand side there is a risk map of how river levels and we compare them to, and we color code them against known thresholds. On the left hand side there is a little, as we call this, the uppy downies. It shows the direction of river levels in water courses there over the last couple of hours there, and it just gives a quick indication. So I just show the left hand slide there is typically of a reasonable day. This slide here shows a typical day that you know you're going to have some problems there. A lot of reds. It's color coded there. It's very handy there. You can see where your problems are. You're having problems in the west of Ireland there, and by the look of that map, you can see a lot of oranges there. It's very intuitive there. You can see that there is going to be problems probably in the Midlands and the South in the next couple of days if the rain continues. So as part of the communications there, we reached out to the local authorities, and as part of the communication strategy, we wanted to reach out to the local authorities as our main stakeholder, as one of our main stakeholders, because the local authorities are the lead agency, they're the principal, the PRA, the principal respond authority there, or agency. They are the lead authority in flooding and major emergency management. So we basically wanted to talk to them. We wanted to get a known contact. So we created the role of a severe weather and flood liaison manager. Well, it's not a great title, but it's what we have. It's the SWFLMs. And we wanted to have a known contact. And what we wanted them to help us ensure that the right communications went to the right personnel. We asked every local authority to create 2 liaison managers, because as you can see during the summer, bad weather just doesn't happen during the winter. It can happen during holiday times as much. And training was rolled out this time last year to liaison managers. Actually, after this meeting, we have a regional meeting or a routine meeting of all the severe weather and liaison managers today at 2:30. So we're meeting them there. The liaison manager is a point of contact. It is complementary to the SWAT team. It's not meant to replace the SWAT team. It should be of a liaison manager should be of a sufficient grade to be able to coordinate the streams of, in other words, who within the local authority or within the stakeholder gets the message. He should manage as I say, the distribution list, or manage the individual email addresses, who we actually send out the notification to, or the daily flood guidance statement, or the weather warning to. We're not asking them to, they're not the people who decide on flood risk. The liaison managers are the peacetime contact. They ensure that when we have to push the button and contact someone in the local authorities, that the right message goes out to the right person. So it's a very, very important job there. And they're also the person in the local authorities to help us and report back on impacts after a weather event, or they're the sounding board for kind of new products and new services there. So I probably went on a little bit longer than I should have there, but that's where we are that's where we are at the moment now. And I think Rosemary is going to just talk about where we are. I've covered the trial, how we communicate, what our products are. I think Rosemary is just going to talk about where we go from this after our trial is kind of finished and the next stages. So.
Thanks for that, Stephen, and hopefully now you can all see my screen. So the road ahead. So Stage 1 was meant to be over 2022. We're running slightly behind, but we're not too far at the establishment stage. So what are we going to do after we've established ourselves and looked at the catchments and done a national coastal thing? So Stage 2 has not been agreed yet. So this is our opinion. It is not based on any facts, just to be clear. Improvements to the existing river models. All we've done to date is catchment models. We need to get into more details and do more detailed catchment, more detailed localized river modeling. Finer river scale models, more localized models. Different sources of flooding. We need to look at surface water. We need to look at groundwater. We also need to look at further developments. That this is where the stakeholders can influence the plan. What do you want to actually see? And international experience showing this take only up to 10 to 20 years to set up flood forecasting centres. Remember, we're just in year 6. So there's going to be many different stages as we approach the end of year 1, or not year 1, stage 1. So it's another while before we go operational, just to be aware. So what kind of things are you seeing from us? We will hopefully at the end of stage 1 have fancy things that'll be able to be issued as at the end of our non-operational trial. Flood advisory and flood alerts will be issued out. But what other types of projects are we actually undertaking? Well, many of you might be familiar with this map. It's the real map of Ireland, as I like to call it, and it is named by GSI and the Marine Institute. The Irish marine territories extend beyond our coastline for up to 220 million acres, an area more than 10 times the size of the land mass of Ireland. The real Map of Ireland was developed for using seabed information gathered as the major programme for mapping of Ireland's entire territories. The programme began in 1999, and the Irish National Seabed Survey it conducts today as Infomar was a joint venture between GSI and the Marine Institute. It's one of the largest seabed mapping programs. So why am I talking about this? Well, we need to look and model this area to get the idea of the coastal flooding. So it's a huge area, the coast, and in stage one, we really haven't addressed it. And according to the latest IPCC report, it is very likely that the state of global sea rise means that during the 21st century, the one we're currently living in, all representative concentrations to integrate that there is going to be an increase in ocean moorings and a loss of mass from glaciers and sheet ice. Climate change, what does that actually mean? We're going to get between 0.25 metres to 1.59 metres in a medium scenario across the world in sea level rise, or 0.16 metres to 1.1 metres in the high end scenarios by the end of the century. In Ireland, only 1.9% or 40% of the population reside within 10 kilometres of the coast. All our 4 major cities are low-lying coastal cities: Dublin, Cork, Limerick and Galway. And more than 40,000 people are within 100 metres of the coastline. From the CFRAMs, from the OPW, 19 areas have been identified as communities are at risk in a current scenario for coastal flood risk. Never mind if we put the medium or high end scenarios predicted in the IPCSS. So we developed a national coastal flood forecasting strategy, which is in line with Éireann's strategy to deliver a high level national flood forecasting service. The objective of the strategy is to operate a reliable flood forecasting system for the Irish coastline, along with support and advanced coast and ocean observation network for the coastal flood forecasting service. So what exactly am I talking about? Well, we've identified a need to develop the coast side a little bit more than what was done in stage one. So for stage two, we're going to look at observations, because every good model needs observations. We also need the coastal weather conditions, we need tides, waves and surge. We're going to expand on the existing observation networks that are already out there with other stakeholders, with the Marine Institute, with, I'll list the stakeholders in a minute. We're going to look into coastal models for coastal weather, tides, surge and waves, and make sure whatever we're doing is in line with international best practice and advancement in this area, because over the last number of years, an awful lot of advancements have occurred. To run coastal models, it's the same as running a weather model. We need a HPC system. So in Éireann, we have joined with the Danish, the Dutch and the Icelandics and have built our own supercomputer up in Iceland, which is going to be operational in the middle of next year. And within that, we will have the capacity to run a coupled ocean atmospheric wave kind of system is what we're hoping to do, but it's built in and we now have the computer capacity to do it. We also, most importantly of all, on behalf of myself and Stephen, need the experts to set up and run this service, and we'll be recruiting more hydromets into Éireann to carry out and aid us with this work for the National Coastal Flood Forecasting Service. So anyone who wants a job in Éireann as a coastal flood forecaster or as a regular flood forecaster, watch out on publicjobs.ie. So these are the stakeholders we'll be engaging with. We will be engaging with the OPW, the local authorities, Irish Lights, the Marine Institute, the Department of Transport, probably Defence as well, actually, the Geological Survey Ireland and Irish Water, to name but a few. Internally, we'll be dealing with the floods, the NWP team, the research section, the climate section and the forecasting division to help us deliver on this new strategy. So to produce inaccurate coastal flood forecast models, we require observations and how well they forecast. Éireann intends to develop coastal observation for Ireland, primarily for flood forecasting purposes, and to build on existing networks. So we have looked into all this stuff, and we carried out one project on this with Irish Lights, which started 18 months ago. So the aim was to increase the number of buoys, tide gauges and new technologies included. So Éireann and the Commissioner of Irish Lights are running a trial where we've deployed 4 wave sensors and additional equipment onto their navigation buoys. The aim was to identify if they could be used for flood forecasting purposes. So where have we gone? We've gone into different ocean locations around the country to get a variety of conditions. So we've one up in the South Hunter, we've one in the Splá in the southeast, we've one at Finnis just off the Éireann Islands, and one in Ballybunion just off the Clare coastline. So these have all been installed, and some of them have been transmitting data for over 12 months. And the information is actually now, if you look on METAéireann.ie website, and the buoys page, you will see these new wave buoys in here. And then we have the data where you can click on and see the recordings of the data over the last 3 days in terms of wave height, period, direction, and the temperature of the water. So we are carrying out verification project at the moment, where on each of the locations we're deploying wave buoys in parallel to them. And once all the data analysis done, we hope to be able to expand the project. And there's a possible another 72 locations for wave buoys where we can do a similar work with Irish Lights over the next number of years. So far the results have been positive, but we're just making sure the science is correct before we invest our money. Another project we're working with is the Enchanting Emergency Management and Response to Extreme Weather and Climate Events. It's called the Anywhere Project. The main goal of the project is to provide a platform that produces a multi-hazard early warning system. So this is beyond flooding for Ireland, and we're using an existing system that was developed under the Horizon 2020 project, and the same consortium is developing the same system now for Ireland that they developed for Spain. The principal objectives of the Anywhere is to enable society as a whole and the main response agencies to respond more rapidly than today to extreme climate and weather events. The project is a pan-European platform of extreme climate risks. To date, there has been 7 pilots set from regional to national level. It will provide a decision-making tool for various authorities and provide state-of-the-art early warning system to help eliminate or if disasters, hopefully, or reduce the extent of them. And the key stakeholders are expected to be the NFFWS and the principal response agencies and the local authorities. A shift to impact decision-making forecasting for weather events is a main goal in the 2017 to 2027 METAéireann strategy development plan. There are increasing vulnerabilities to the impact of weather due to climate change and urbanisation. We face the threat from high impact weather events. The weather related hazards such as flooding, wildfires have potential to cause personal injuries and loss of life, and to damage properties, infrastructure and the environment. As the climate change progresses, future weather is likely to become even more challenging with an increased frequency and severity of extreme weather events. The Anywhere system is divided into 8 main hazards, so there are many different data sets and algorithms associated with each of the hazards. The Irish system is set to be developed to incorporate the ingestion of hazards that METAéireann's weather warnings, flood alerts and advisories. METAéireann and other Irish observations in terms of weather, radar, air quality, METAéireann's Harmony and MWP model, the ECMWS forecast model, along with the EFAS awareness systems, flood warning and forest fire warning systems will all be incorporated into Anywhere. So one-stop shop for any multi-hazard is what we're aiming to do. There's a separate menu with static information on the vulnerable areas. For example, the CFRAM's flood extent maps can be shown alongside different receptors like hospital, roads and schools. So the area that are potentially most at risk can be identified. Visualization is orientated towards potential incidences. These can be anticipated by the real-time hazard data and local vulnerability information. Alerts can be issued to relevant stakeholders in relation to potential issues, is what we're aiming to do. And I love the name of it. It's called the Argus, is the name of the developer. So if any of you are ever going to be users, you'll get emails out to the Argus system, and it's not anyone sending you a catalogue, just to be aware. So the slide shows the concept and the approach. It's been developed as a web platform. It's a cloud-based, so it's accessible from anywhere that has the internet, which is very important for any emergency response system. It's hosted by the AWS Amazon Web Server. It's geo-resilient and is hosted at 2 different locations. There's one in Ireland and one in France. It's modular and can ingest data from multiple sources. It pulls in NWP, radar, satellite, and radar composites, along with products from EU platforms such as EFAS, and anywhere that runs a series of algorithms and forecasts and assess the vulnerability to protect hazard impact maps. They're displayed in the system alongside with local sensor details, weather, etc. All products can be assessed even if there's no severe weather, so they can be used to the system. In emergency simulation, alerts can be generated. They can be displayed or sent as notifications by emails or text. So that really is that it's going to be translated in impact information. There's going to be integration, the impacts of forecasts with high resolution. So you will look at the weather forecast and be able to see the impacts. So that's really what the Anywhere is about. And hopefully you have a few questions for us on flood forecasting. And thank you for your time today.